name is Brian Eoff, and I'm a data scientist at Bitly in New York. And what I want to talk to you about is infodiversity, and I subtitled this, Why Finding Your Arch Enemy is More Important Than Finding Your BFF. And I don't know how common that phrase is, but it just means like your best friend forever. Okay, so what is Bitly? Bitly is an online URL shortener. It's used heavily on Twitter and Facebook. Every day, it's a place where people can save and shorten and share their content. So every day, 160 million links, roughly, get clicked on, and Bitly gets all the data on that. Geographical information, IP address, browser information, everything across all domains almost, or many domains on the internet. Each day, people encode 250 million links that they share on various services, and we currently power 25,000 URL shorteners for such things as the New York Times, the Washington Post, ESPN, and so on. Back. So one of the interesting things from this data is we can understand how stories propagate online and how they get shared. And one of the most interesting things I've worked on recently is understanding how a local story becomes a national story, becomes a political story. And this was work we did with Bloomberg discussing the murder of a youth in Florida whose name was Trayvon Martin. And it went from being a very local Orlando crime story, and 2 weeks later it became a national story, and then a few days after that it became a political story. And it was just interesting to see the propagation and how, for about 3 weeks, there wasn't much national attention on this story and what caused it and so forth, and how it moves throughout our country. We also have a service we call Realtime, which we take all the data that we get and we try to give it back to people to show them what is the most popular thing currently going on social networks. And I took a screenshot of this yesterday in the US. Justin Bieber got sick. People hate iOS maps. And Google did something which caused controversy, which is not incredibly surprising. So I guess I'm going to defend recommendations. I'm going to defend recommendation engines a little bit. And I think we're all familiar with these. We encounter them every day. And they're not very good. They're not. This is my Amazon recommendation right here. And because I bought a Dennis Lehane book, it's recommending me the others' books. That's kind of boring. This is my who to follow on Twitter. I took this yesterday. I know Bostock. I know a lot of these people. People I follow these people. And this is how it works from a graph point of view, right? I'm the lower node. I follow 4 people. Those 4 people all follow someone. Hey, you should follow this person. And it's very obvious. It's how we go about doing this so far. Okay. So I studied recommendations in school. I've written about them. I understand the concept. And then it came the day where I had to write one myself. And I knew the filter bubble, I knew echo chamber, I knew homophily. I wasn't going to fall into that. I was going to do it right. It was going to be amazing. I was naive. Yeah, so this is Bitly's current consumer page. And one of the nice features it has on it is a network view, where you can see people who you follow in various social networks and what leaks they short and what leaks they saved. And the top one is my colleague, Anna Smith. And she posted a picture of 3 of my colleagues running, well, 2 running and 1 riding a skateboard. And at this point, I kind of, on that right-hand side of the page, I want to put a friend recommender. You should follow these people. So I went about it in the way you go about doing these things. I used a similarity metric, like cosine similarity, or Jacquard, or Benassi. There's tons of them to find people who are similar than you. And then I wanted to add something additional to it. I created a front-runner score. It's how fast do people save content? How interesting is it? Which of your friends saves the most interesting content first, and how does it migrate through the network? And then I took into consideration the concept of maybe you don't want someone who just broadcasts. Maybe you want someone that you can go back and forth with. They share information, you share information. It's a very mutual relationship. Okay, anytime I try to tackle a problem like this, I try to figure out a metric to determine if I'm successful. That's just the machine learning approach. That's engineering, that's science. And for this, I had all the things people shared information-wise, and I had their social graph. And I thought, if I could, from just information sharing, recreate your social graph, I did pretty well. I was good. Hopefully not perfectly, even though that would have been an interesting result. Hopefully, I suggested nodes that should be in your social graph that you weren't, and I could recommend those. I consider that a success. And I was successful. I was able to recreate your social graph just from your information needs. You know, it said things like, I should follow Hillary Mason. She's my colleague. I do follow her. I should follow my best friend. I do follow him. You know, these things, and you applaud yourself because the algorithm works. It's obvious. It's giving you back. And it was disappointing. It worked. And the problem was it was recommending very safe things, like, oh, that's obvious. And later that evening, I was at home and I was watching the movie Heat by Michael Mann. Don't know if anybody's seen this movie, but it's a metaphor I'm going to use. And so in Heat, there's this, it's kind of a tale of police and robbers, and it's told over Los Angeles. And there's this amazing scene where the cop has coffee with the robber. And they sit, and they're on totally opposite sides, and they sit down, and they have coffee, and it's an amazing conversation. And I just thought, no recommendation engine would ever recommend these two people. You know, he's a cop, he's a robber, he's been in jail, he went to school, you know, he has prison tats, he doesn't. You don't recommend those people. But the conversation they have is amazing. Like, and there's so many examples of this in film and literature. You know? And let's see. So I kind of thought about clustering. Like, how would I cluster this? And on the left, you have law enforcement. On the right, you have criminals. And I would recommend criminals to criminals and law enforcement to law enforcement. And I'd be like, yes, success. But it's boring. And so I was trying to think, how could I recommend these two people? And I started just thinking of this arch enemy concept. Another example, just from film, is the TV show The Wire, in which you have Stringer Bell and Jimmy McNulty, two very opposite sides. But they have this respect, they have this relationship, they like each other, you know. And in American culture, another example is Jon Stewart and Bill O'Reilly. These people are totally on the opposite sides of the partisan issue. Bill O'Reilly is conservative and very boring, and Jon Stewart is, you know, liberal and very funny, but they clearly have a respect for each other, and they debate, and when they talk to each other, it's interesting. So you have to think, we're not recommending well, because we're never going to make those recommendations, for a variety of reasons. I mean, think in your head, any fiction, any literature, any story you like, there's always an archenemy. Sherlock Holmes, Professor Moriarty. You can just go through these examples of these amazing relationships that are interesting and provocative, and they bring the best out of people, and you will never get those in a recommendation engine. You just won't. So the question becomes, we all know about the filter bubble, we all know about the echo chamber, we create these algorithms. What are you prepared to do to change it? And the thing happens that you have to be okay with being wrong. Like, it was an example of how this personalization is terrible, but I can explain terrible personalization. I can explain why I recommended you follow these people. You should follow these people because you follow these people. You should buy this book because you bought these other books. All these recommendations are really safe. But if a recommendation engine just said, look, read this. You've never read anything like it, none of your friends have read anything like it, just trust us, read it. It would be on the front page of Hacker News. They would be ridiculed. I mean, you know, it's this person's never read a romance novel. Why are you recommending Jane Austen? Because we are so quick to critique algorithms. Because we love it when they fail, don't we? It makes us human. We're a little bit better. We got something. Algorithms don't work that well. And so when they make a folly, we kind of push it to the media. It's an example. But my point is, to do something interesting, it's got to make follies. I became okay with this idea that I was okay being wrong. That every once in a while, I wanted my algorithm to recommend someone who you shouldn't never see, just to see what you did to it. I want an algorithm that pushed the edge. You know, you're a conservative, recommend you a liberal, just to see. Maybe it happens, maybe it doesn't. Maybe we can make that gap. But reach out and try to actively find the information to give you a better picture. And it's risky. It's risky and it's uncomfortable because we don't have metrics for success. You know, I can't point to root mean square error and say I won, or, you know, my cross-validation is going to be off. But I think it's going to introduce a much more interesting set of algorithms, and it will make personalization, recommendation, it will get them out of their filter bubble and break homophily and hopefully open people up to new things. Or at best, we'll figure out new metrics to use to recommend things. All right. So I thought we were doing questions. I guess not. But my name is Eoff, and thank you for giving me the time.